recording our meeting. Cool. Can everyone see my screen?
Yep.
Fabulous. I think we can get started. All right, everyone. Welcome to our first workshop of the semester. So this is a collaboration between Software and Computer Engineering Club and mlatsjsu. And the topic of our workshop today will be to introduce you to PyTorch and also give you a high-level overview about what machine learning is. Before we get into all of that, actually, as I said earlier, so the goals of this are to introduce you to PyTorch machine learning, as well as give you an idea about what a workshop should look like for when or if your committee chooses to do one. So before we get into that, I have some exciting announcements. So first announcement is that we have a ML for High School program. It's an 8-week program where we will be teaching underrepresented high school students from the East Side San Jose High School District. We'll be teaching them machine learning and Python. And this is tentatively planned to start on October 4th. The other thing, another announcement I have is we will also be hosting a climate change and AI panel. On the right, you can see the 5 panelists that we were able to recruit. So Dr. Flora is a senior research scientist at Stanford. Her work has to do with social messaging around climate change. Priya Danti is a PhD student from Carnegie Mellon, and she is a co-founder of climatechange.ai. Michael Gerda is a senior firmware engineer at Tesla. He is an alumni of San Jose State, and his work has him working with Tesla's energy products like Powerwall and PowerPack. Chris Anderson is a current PhD student at Stanford, working with forest fires and ecology, and he's a co-founder and CTO at Salo Sciences. And lastly, James Pebberell is the CEO at GreenSight. So impressive panel, and we're really excited to be hosting a conversation with these panelists concerning how students can use their backgrounds and education to make an impact towards climate change. Although the date hasn't been crystallized, it increasingly looks like it'll take place on November 7th, but more information will be coming your way very soon. That's all for announcements.
How would we register for the climate change panel? Do we have to sign up, or can we all just go?
Yes, so you will have to register. It will be either through Eventbrite. Eventbrite, you'll have to request a ticket, and that's how you'll get access to the link, or we'll send it out through Google Form. The logistics of that will be, like I said, all the logistics will be crystallized by next week. Anyone else have any questions about the ML for High School program or the Climate Change and AI panel? Yeah, okay, cool. Okay, Vlad, by the way, your hand's still raised. So I don't know if that means you have a question or it was just a, okay, cool. Okay, cool. All right, so we can move on to the presentation. Gautam, take it away.
There is a question in the chat. It says, for ML for high school, are you looking for people to help teach?
Gaston, I'll let Gaston answer that question.
Always looking for more people to help. If you'd like to help, please feel free to message me directly on Slack, and I'll get you up to date on where we are with the project.
You can also join the Proj ML for High School channel in Slack too.
Yeah, I'll add you to that. You don't need experience. I think we may or may not have said it before, but a willingness to learn is almost more valuable to experience when it comes to stuff like this.
I agree. Any other questions? Actually, just as a poll, informal poll, I'd like to see how many people are interested. So if you're interested in attending the Climate Change and AI panel, can you please raise your hand? Cool. That's a lot of raised hands. That makes me very, very happy. I'm very excited for this. So fabulous. Thank you, everyone. Let's move on to the main event today, which is our workshop.
Yeah, thank you, Gaurav. So, hello, everyone. So today I'll be talking about the roadmap to machine learning. So basically, this roadmap focuses on 3 main points. The first one is the high-level intro, which explains the machine learning and the deep learning concepts. And the second point is the common tools and frameworks used in machine learning. And the third point is the expected outcome, which is the understanding more about how machine learning works in terms of its functionality and the coding capability. Before I start on with the roadmap, let me answer this question. What is machine learning? So to do this, I am going to explain by showing some cool applications, which tells you what can you do with it, followed by its process. And then lastly, what types of machine learning techniques are there. Here, if you see the first and foremost application of machine learning is self-driving cars. So self-driving cars is actually a machine learning being experimented by many companies. So this application is approached by 2 different departments of machine learning, which is computer vision and reinforcement learning. Over here, computer vision performs its role of taking inputs, which is the images of the surrounding, and then it analyzes the image. Whereas the reinforcement learning does the decision part of the input received. Like for example, like when you see a person standing in front of a moving car, the computer vision takes the image and analyzes the person, while the reinforcement learning makes the decision part of stopping the car. This is how self-driving cars are approached. Apart from self-driving cars, computer vision is also being used for object detection. So if you see the image, it shows multiple objects being detected using computer vision. Object detection is widely used for tasks like face detection, activity recognition, and tracking objects. Like for example, like when you see a soccer match, the object detection is used to track the ball's movement, same as other sports. But something more interesting application of machine learning compared to the previous 2 applications is GAN, Generative Adversarial Network. GAN actually lets you generate data which replicates like another data. This is actually done by learning the patterns of the existing data, and then it generates a new data. If you see the picture on the left, which portrays images of humans who look real, but they aren't. Actually, you would have also heard of deepfakes, who also uses GAN. So GAN is basically primarily used for creating imaginary objects. And the last application of machine learning is NLP, natural language processing, which is a common application for quite a while. You might have heard of different voice assistants like Siri, Alexa, Google, and Cortana, who uses NLP to interpret human language and then give feedback based on it. Now that we have an idea of how machine learning works, how does it fit into artificial intelligence and deep learning? Let's talk about it. Like if you see the image on the right-hand side, AI is just an overall picture of machine learning and deep learning combined. AI makes the overall machine look smart, but how do you do that? Through machine learning. Machine learning plays a vital role of training models using data sets. It includes building all algorithms. The classic version of machine learning is humans doing the feature extraction on data. This puts a lot of effort on humans. How do we automate the feature extraction? This is where deep learning comes into play. Deep learning is a subset of machine learning. The advantage of having deep learning is that it automatically does feature extraction. The key component in deep learning is developing the neural network, which performs an important role. Though the functionalities of neural network sounds like a human brain, it's not. It takes an inspiration of human brain. At the present moment, deep learning is the main focus. With that hierarchy of machine learning, let's move on to the types of machine learning.
Does anyone have any questions up till now? Please feel free to interrupt with any questions. We want to make sure everything is clear.
I got a question, but it's on the computer vision. But it's not like related to the workshop, but it just came to my mind.
Go ahead.
So I was thinking so for computer vision, it takes into like the picture that you're getting, right? And then it reinforces it. So what happens if it's like a rainy day and then you can't see anything outside of the picture? Is that like a no-go? Or it's like, what happens then?
It's a great question. And I think, so the short answer to that is you need data with the data of the road during rainy day. Like when there's rainy day, you need data where like the car sees rainy day images. So it knows how to navigate during that period of time. Whether it's very, very sunny or there's wildfires like we have in California or all of that stuff, you need kind of data for the model to learn.
Oh, I see. That's interesting. Awesome. That's cool.
Great question. Any other questions? Fabulous. Please feel free to interrupt. But yeah, next slide.
Yeah. So moving on to the types of machine learning, there are actually 3 techniques of machine learning: supervised, semi-supervised, and unsupervised. Supervised is a simple technique because all the data are labeled. For example, in an image, if there are cats and dogs and if there's an image that has a label of which one is a cat and which one is a dog, then the model is trained in such a way that the system can detect. The difference between supervised and semi-supervised is that supervised has all its data labeled, whereas semi-supervised has a mixture of labeled and unlabeled data. But the worst part is unsupervised technique, because it has all its data unlabeled. But that doesn't mean we cannot train. Still, we could train using its patterns. One such way to do this is clustering. We can make predictions by clustering the features of the data and then classify the data. With all these knowledge put together, how can we execute this? Machine learning, moving on to the next slide. Machine learning works in 2 formats, the training stage and then the inference stage. The training stage is more of like a child learning the concept. Just like how child makes mistake when learning, we start to train our model with poor predictions and then fix it on a step-by-step process by tweaking our model. With this cycle, our model is trained. Then comes the inference stage. This stage is just like a child attending the exam after practicing all its concepts and doing all its homework. In the inference stage, we test our model with a completely new data. Moving on to the overall picture of machine learning, we get to know our model is ready by first evaluating the performance of model using a test set. So the test set is completely different from the training set. Once we clear this step, then we get to the inference stage, as said earlier, which is running our model in a completely new data. So this is how we get to know that our machine learning model is ready. With that conclusion, let me hand it over to Vlad, who will be talking about deep learning.
Thank you, Gautam.
Awesome. Sorry to interrupt, Vlad. Any other questions? I'm going to keep interrupting and checking if there's any questions. No question is a bad question because there's probably other people who don't understand it as well.
For the types of ML, there were 3 types, right? Supervised, semi-supervised, and unsupervised. So, is there any priority, like depending on what problem we are trying to solve? Like we choose what type of ML we use. Is that right?
It's some sorts of machine learning, if I'm understanding your question correctly, are more suited to certain tasks. But from what I understand, it's very experimental in the sense that you can try a bunch of things and then you tend to pick the thing that works the best. Because while, like I mentioned earlier, there are some guidelines. So, for example, for computer vision, an NLP type model will probably not work very well. It doesn't mean that discounts like any of the other particular forms. There's pros and cons to most machine learning models, and unfortunately, it's very hard to like prove theoretically why you shouldn't use something unless it's designed for a task completely unrelated to what you're doing.
Oh, yeah.
Does that make sense?
Yeah. Because for supervised learning, we have our data labeled. So won't it be better to solve anything with the labeled data as compared to if we have semi-labeled data or nothing is labeled at all?
Right, that's correct.
Yes.
Oh, yeah. You want to answer that, Andrew?
Yeah, I want to add a comment. It also depends on like the type of problem that you're approaching. Sometimes it doesn't make sense to have labeled data. Like say you're trying to analyze a big data set, and you're just trying to find like how does this data like automatically fall into different types of groups. And you don't want to, because you don't know what type of groups they might fall into ahead of time. You just want to be able to find it using machine learning. So that's a case where unsupervised learning might come into play. Then for semi-supervised learning, you can see in this bullet point, especially when labeling data is very expensive, then maybe you only have enough money to label some of the data. And then you want to employ an algorithm which can use this semi-labeled data sets along with all the rest of the data in order to learn a better model. So a lot of it depends on the problem that you're trying to solve. This is a great question.
Yeah, to add on to what Andrew said, you could also start with unlabeled data and then perform unsupervised learning so that you can label your data and then do supervised.
Okay. So unsupervised learning is like the cheapest form of machine learning model that we can use. One of the solutions.
You mean by cheapest as in like least expensive to
Yeah,
perform?
least expensive, yeah.
I would say that there's a cost to both. So although labeling is expensive, having labeled data is easier to like, using labeled data is easier for a machine learning algorithm to work. In general, supervised learning tends to be easier than unsupervised learning. So there's kind of like, there's no like, this is the best way to do it. It's pretty much, there's a cost either way, which cost do you want to pay?
Okay, yeah, that makes sense. Thank you.
Good question.
I had another question.
Yeah, sure.
So for semi-supervised, how does it decide what data to label? For
You mean like initially?
Yeah.
Initially is like based on whoever owns the data, I suppose. They decided what amount of data that they can label.
Yeah, so like, say you're like a company that has a bunch of data. Let's take the autonomous driving. So you have a bunch of data about images of the road. It's kind of hard to label all the pieces of data. So you might be able to have enough money, enough funding to label part of the data and try to infer the rest of information from this labeled data. It's pretty much whatever. There's other constraints that are usually in place that will only let you label a certain amount of data.
Okay. Thank you.
Question?
I have a question.
I heard that there is also a type of machine learning called reinforcement learning. What is actually that? It's a great question. I can try to answer it
There's a
shortly.
video on that as well.
This is the type of machine learning where you don't have the correct labels to label it as supervised data, but you do have instead some sort of reward that is associated with your state. So if you were compared to supervised, for example, you would have the model that will take in the state of the environment of the world that the model interacts with, and the model needs to give you some sort of output for the action that it will take, or the value of the state, depend. And when it interacts with the environment will give it back the reward that follows, and that way you know sort of what's the truth value for how well the model performs. So you don't really have the right actions to take. Instead, you get the sort of sense of how good are your actions, how well your agent, your model performs, and based on that, you can improve your model. So like the reward you say is kind of like a quantized, it's not a quantitative value, not a true or false. It can be true or false actually. For when you might have a game where you only know like whether you win or you lose. You can't really calculate what's the value for each state, so it can be true or false.
Generally, yeah, it's a number.
Yeah, so you can decide yourself how you score. So in the example that Vlad proposed, where you know whether you win or lose, it can be as simple as saying, you give the agent +1 when you win, and then -1 when you lose. So that's a simple reward schedule or scheduling. But let's say you really, really don't like it when your agent loses, so you can assign something like -1000 when they lose.
Great question. If you're interested in the reinforcement learning, join the committee if you haven't already. Yeah, cool. Great questions, everyone. Let's move on.
Now, my name is Vlad, and I will give you a really fast crash course into deep learning. So we can go, now, where do neural networks, deep neural networks come from? They're very loosely inspired by neural networks in the brain, and the fundamental unit for such a network would be a perceptron, and all it does is it takes a number of inputs, it multiplies it by some parameter that we call weights, and sums them up, gives us the output. Now, one perceptron or neuron is not really interesting, can do a lot of things, which is why neural networks are actually much more interesting in that sense. Stacking multiple neurons, adding them together into several what we call layers allows us to get some interesting results. We call these neural networks deep because they are composed of several layers of these neurons. Now, the reason why they are somewhat effective is because with the proper parameters, each next layer can learn pattern or feature building on the previous layer. So let's say you want to classify an input image as a dog or a cat. It can learn the basic features in the beginning, in the first layer, like the basic patterns as lines that are tilted in some way. And on the next layer, it can combine those to produce somewhat more high-level features like some basic shapes and so on, until it gets to the like final level layers where it gets some sort of, you can get some sort of features like an ear of certain shape or a mouth or an eye. And those can be further combined to actually produce something that actually decide whether this is a dog or whether this is a cat. Now, the way this will work, usually you will have your input, so for example, an image, and an output as a label. We can go further to the next slide. Now, getting this output value from the network is called a forward pass. Fortunately, we can just initialize our parameters in such a way that they will give us proper interesting classes on the output. This will be initially some sort of garbage because we can only initialize the weights or parameters in a random way. In order to improve them, we will need to update our model several times. And to do that, we will first do a forward pass on several forward passes on some sort of data that we know the correct output for, that we call also a training data. And then when we know what sort of output our network gives us, so it will give us an incorrect output, but we will compare it with the correct output, the truth value. We will get some sort of value that we can update our parameters with in that case. And we will perform this update several times. We will do several passes forward. We will do a backward update. So that is called a backward update or backpropagation. We will do this forward pass and backward pass several times in the training set, in the training session, and we will get some sort of model that can actually give us some meaningful outputs. On the next slide, we can see a very simple model that is just trying to learn the function to approximate this to these data points. We have one input, we have one output, these several data points, and this is how the simple model would look like. Basically, it is an optimization problem where we would want to minimize our error or loss, as we call it, with respect to weight and bias, which are basically the parameters of this model. And to update these weights, we're using an optimizer function that actually helps us to calculate the direction and how far we want to go to update our parameters.
Hey, Vlad,
Doing several updates. Yeah.
What's the loss function?
The loss function basically allows us, it's basically a calculation of how far off we are with our current prediction from the truth prediction. Any other comments on that? You want to expand on that? No, that's fine. So yeah, basically we will use the optimizer to update, to get the update for our parameters and update our model. And over time, that will lead us to minimize our error. That's the basic principle. Now, any questions so far? Yeah, that's actually a question from us. If anyone can think of equation that we could use for the loss or the error.
Does deep learning include linear algebra and, let's say, statistics based on this model?
Yeah. Yeah.
And calculus as well. Calculus is where you're trying to minimize the loss.
Mm-hmm.
Yeah. Linear algebra comes in when you have matrices of parameters. So you're trying to learn a lot of weights. So that's where the linear algebra comes in. And statistics is because you're doing statistical analysis here. So, good question.
Okay, awesome. Is there like a subsection for just deep learning here that I missed? I arrived late, by the way.
What do you mean just deep learning?
I'm not sure. For example, we're doing a series of projects, a presentation. One was reinforcement learning, another one was traditional. Is there like one for just looking at this?
I think he's speaking about a committee for deep learning.
Yes, sorry.
So we don't have a committee just for deep learning. And I think what that entails usually is like vanilla neural networks. So, like vanilla neural networks like this. Unfortunately, these neural networks aren't too interesting. They're great for foundational understanding, but there's not a lot of great applications. But I think things become interesting when you do computer vision or NLP, where there's applications of that. So that's why we don't have specific deep learning committee.
Right, basically every single one of our committees, except for the traditional machine learning committee, focuses on using deep learning for each of these applications. Like you have deep convnets for computer vision, or other deep recurrent networks for NLP, things like that.
Good reinforcement learning.
Oh yeah, RL uses deep neural networks as well. Does everyone understand this function? I think this is a very important graph right here. If anyone doesn't understand it, say so, even if you don't have a specific question. Okay, cool. Sounds good. We can move on. So now we'll start talking about some tools that you can use for machine learning. Our focus here is on machine learning. And in machine learning, some tools that are used are scikit-learn. And this involves a lot of algorithms of classical machine learning methods. For deep learning, you can use low-level languages like PyTorch and TensorFlow, or higher level languages like FastAI and Keras. So now we'll start our
libraries, not languages.
Oh, sorry. Yes, these are all libraries, not languages. They're
languages
all
Python.
Off of the Python language. Unless you want to do coding in C++, we use Python in this club. So now we will move on to our workshop. So we put together a PyTorch workshop for you. But first, there's a bunch of installations you all need to do. So the first installation is Python. So this is at the point at which we kind of move away from the lecture type deal, and we're going to move towards kind of interactive and like getting your hands dirty. So now, does everyone have Python installed? If not, please do so. There's instructions on the screen. And you can access these instructions from the slides in the Slack channel. So if you have questions about how to install it, if it's not working for you, now is literally the time for you to start asking.
So right now people are installing things, right?
Correct.
They're asking for it. Okay, cool.
Yes, you should be using your laptop and trying to install Python. So if you have Mac, Windows, go to python.org, downloads, and install it from there. If you have Ubuntu Linux, then your life is easy. You can just run this command in your terminal. All right. Can I get a feedback about if you're raising, can you raise your hand if you have, or if you are installing Python right now? Cool. If I can't see your video, it's hard to see if you're raising your hand. So also raise it in the chat as well. Okay. Cool.
Wait, raised hand means currently installing Python, right?
Correct. Yeah. If you are raising your hand, you are currently installing Python. I assume anyone that's not raising their hand right now already has Python installed on their machine. If not, please raise your hand.
Okay, if you already have Python installed and you want to jump ahead to the next installation steps, you can look at our slides, which we posted in Slack announcements. You also have to install this thing called Conda, which Gaurav will talk about in a bit.
Yes, I'm going to give people about 2 to 3 more minutes to install Python, and then we'll move to Conda installations. Please ask your questions. We want to make sure you can follow along in our workshop.
Yeah. In the meantime, while people are installing, feel free to ask questions as well about some machine learning, any interesting ideas that you might
I
have.
have kind of a question. So yeah, when you install Python and then you install Conda, do you have like the situation where you have like 2 different Python environments, I guess? Because like whenever I try running like Python through command line, I never get like the packages I install with Conda and stuff. And yeah, it gets kind of messed up like that.
Right, so, I guess we haven't talked about what Conda is yet. So what Conda is that it's a tool to manage isolated environments in your computer. So as you all grow as software engineers, you'll soon realize that different projects basically have different dependencies, like different libraries that each project is supposed to use. Like there's Python 3 and Python 2, for example. No one uses Python 2 anymore, but like say you're using PyTorch in one project, but then another project uses a different version of PyTorch. You don't want to have to like uninstall PyTorch and reinstall it every time you switch between different projects, right? So what we use is this tool called Conda, which basically is like a little isolated world on your computer, which has the correct versions of things installed. So then Jason's question about when you install Conda, does that interact with the Python that you already have installed? The answer is yes. The Python that you already have installed is like your global system Python, which like the rest of your system can interact with. And then like your individual Conda Pythons, that's like project specific. Does that answer your question, Jason?
Sure, yeah.
So then to activate those libraries, or to interact with those libraries, you have to activate the environment.
Shifa, yeah, you can use Google Colab. Our workshops written in Jupyter Notebook. Google Colab tends to be buggy at times, so that's why we defaulted to that. But I think you're more than welcome to use. You're more than welcome to use Google Colab. I believe you can copy and paste the GitHub URL into Google Colab and import it like that.
Anaconda is basically Conda, right?
Sorry, your volume's a little low. Could you say it again?
Anaconda is okay, right? That's part of Conda, or Conda is part of Anaconda. Okay.
Anaconda is fine.
Yes. Okay, great. I think we can move on to, I'm assuming that everyone has Python installed. Please ask in the chat if it's not. But now we'll move on to kind of the rest of the installations. So the required dependencies for our workshop today will be Conda, which is your entire environment and package manager. Scikit-learn for your machine learning algorithms. Pandas is to deal with large sets of data. Jupyter Notebook is our interactive notebook setting where you can run notebooks and kind of, this is where you can test out different things very fast. And it's much faster to interact with than a regular Python file. And then PyTorch, which is our deep learning framework that we are using. So I think Andrew already explained what Conda is. So I'm going to skip this.
I have a question.
Yes.
In here, there's a download option called bit bash and bit package in the website. And which one should I download?
Is this for Conda?
Yes.
And you said git bash and git what?
In here, the file name, there's two types of file name. Miniconda3 Mac OS X, 64-bit bash, and 64-bit package.
Yeah, I know the answer to that question. Which operating system are you on?
I'm using Mac.
Yeah, if you're on a Mac, you can install the, I think the .package file. Basically, the bash file is it's like a bash script that you can run from command line to install it, which works too. But if you prefer drag and drop with the GUI, you can install the package.
Oh, okay.
Cool. So, also, any other questions? Fabulous. So, why do we use Conda? So, as Andrew was alluding to, it allows you to create separate isolated environments with packages of different dependencies. So for example, if you're downloading some kind of code online and they're using a very old PyTorch version, then you need to create a specific environment to run that file in, but you don't want to mess your global Python up. So these isolated environments allows you to run, have the specific dependencies of each individual software project. Okay, so the first step here is to download Miniconda. So if you go to docs.conda.io, you can go to, you can pick the 64-bit option that corresponds to your operating system. So whether it's Windows, Mac OS, or Linux, just click the corresponding 64-bit installer. On Windows, you'll have to use a special prompt called the Anaconda prompt. But for Mac and Linux, you can just use your regular terminal. So make sure, if you're using Windows, make sure to use the Anaconda prompt. Most of the bugs that you might have will be solved by that. So again, if you have Windows, use Anaconda prompt. To verify your installation, run conda help to verify your installation. So if you're at this website, you can go ahead and select the correct installer. So Windows, Mac OS, or Linux.
Yeah, and someone also asked about Anaconda, and installing that is fine too.
Yeah, Miniconda is just a smaller version of Conda. It has everything you need, and it just tends to be lighter. But Anaconda, it works great as well. All right, I'm gonna give people a couple more minutes to install Conda. Please comment in chat if you do not have Python installed. So if you do not have Python installed, please reply in chat. Thank you. Does everyone have a committee that they've joined and they're interested in? Is there anyone that doesn't? Cool. Are you, I believe I've seen you at the machine learning committee, if I'm not mistaken, Felix.
Oh, I was in both. I was the one guy without a camera or mic.
Yeah, I think I remember. Okay, cool. Feel free to take your time.
Maybe so we can see the status of everyone in the participants chat. They can raise their hand if they've installed Python, and they can click go faster if they're already done with installing Miniconda.
Quick question. Probably someone already asked this, but in the Anaconda one, are we supposed to add the Miniconda 3 to my path environment?
Yes.
You should.
Yes.
Their website recommends not doing that because it can lead to errors. So.
Wait, where on the website?
Like
They
on the
had,
Anaconda
like,
website, it recommends not adding
in
it
the,
to path.
in the installation path, they had like some option that says like, yeah, there's some way we do it for you or something. I don't remember what the option was.
I click yes, do it for you.
But this is for I'm pretty sure this is just for Windows.
Correct.
Yeah,
Everywhere
I think I
else
had
you want
to.
to add it to path.
Yeah, I had to do it manually, I think, because it didn't work or something.
So for Windows, yes, just go ahead and figure it out.
Well, it shouldn't be. I don't know. They give you like your own special program for Windows because they prefer it not to be added to path because it breaks some stuff sometimes, requiring you to reinstall. So I would recommend it not adding it to path.
On Windows, right?
Yeah, only on Windows. On everything else, you're good. It'll
OS,
get
Linux,
set to use the terminal.
Okay, I have Windows, so I'm not going to do that.
If you're using it in an IDE, it will detect the Anaconda Python anyways, so it's not a problem. It's only a problem if you only do stuff on the command line and you don't want to use the Anaconda prompt for whatever reason on Windows.
Okay.
Cool.
So I am. So I only see 2 or 3 people saying that they have Conda installed already. I assume people still need more time.
Right, click go faster if you've finished with Conda.
Okay, cool. And this is going to be my last check. No one else needs help with Python installation, right?
computer networks.
Hello? I couldn't hear you, sorry. Okay, cool. I'm going to move on to the next slide. So now we will use Conda to install everything besides PyTorch. So if you are on Linux or Mac OS, you can run these commands in your terminal. For Windows, please use Anaconda prompt. So you can run these 4 commands: conda install scikit-learn, conda install matplotlib, conda install jupyter, and conda install pandas. So you can run these in your terminal for whichever one works for your OS. Again, Windows use Anaconda prompt.
We'll be screen sharing the Jupyter notebook when we present it too, right?
Yes, I will be.
Maybe you can demo these commands in the command line then.
I could do that.
Although it's probably already installed for you.
Yes, it is, but that's not a problem. It'll just tell me it's installed. Okay, cool. So can everyone see my terminal?
Can you maximize the zoom in on it? Like a Control plus or something?
Okay, cool. So then right now I'm in So right now I have, I'm going to install conda install scikit-learn and enter, and then it'll install scikit-learn for me. I guess I don't have scikit-learn installed.
Good thing we did it.
I think it also updates if you're on a lower version than that.
Yeah, I just don't think I had scikit-learn actually. Cool. And then when that is done,
like make the window wider. Oh, sure.
Cool. So then I can do conda install Jupyter. And then that'll do the thing.
Yeah, instead of installing one by one as well, you can also just type all the packages at once on the same install command.
Oh, really?
Mm-hmm.
Yeah,
Just
and
a
again,
space after each package, Andrew.
Yeah, put a space.
Yeah.
And if you're already done installing all of these first packages, you can click Go Faster.
And then if you want to install matplotlib as matplotlib, as well as, what was the last one? As well as pandas. Then if you want to install multiple packages, you can just type 2 packages separated by space, and then that should be enough.
All right, and if you're deciding to not install stuff, that's fine. You just put like an X on Zoom so we know that you're just gonna watch and not install stuff.
Cool. So we have all of these installed now. I am going to assume that people either are on their way to installing or have already finished. Please interrupt me right now if that is not the case. Okay, cool. So the next part is going to be to install PyTorch. So to find the specific command that you want to use, I recommend just installing it from this. This will install the latest version. So if you are on, so okay, actually hold up before we do that. So if you are on Mac, whether you have a GPU or not, you only have one command. But for Windows and Linux, there's separate commands for if you have a GPU or not. If you don't know if you have a GPU, you probably don't. So just install the if not one. So you can just go ahead and install conda install PyTorch torch version and -c, and that should install PyTorch 1.6. Is that right?
Yeah. By the way, Gaurav, if you click the link as well, you can choose your operating system and it will show you the exact command to install. Just want to show that to people.
Yeah, so if you go to pytorch.org, you can go to your OS, which PyTorch build you want, your OS, your package manager. So we're using Conda. Language, we're using Python. CUDA is basically what version of GPU driver you have. So if you don't have a GPU, just press none. If you do have a GPU, then select your driver. And then you can just run this command.
Oh, to clarify, I'm pretty sure this will only work with an NVIDIA GPU. So if you are running an AMD one, then you should stick. I mean, you can install CUDA, but it's not going to do anything. So it's preferable to pick the GPU-less option. And before, if you're not sure, like if you're running kind of like an older than 1000 series GPU, you should check and make sure that the CUDA version is supported for your particular model.
Great. So that's how you install PyTorch. Okay, I'm going to clear everyone's responses. If you want us to go to the next step, please press go faster. If not, just keep doing what you're doing. The slides are shared in the announcements channel on the Slack.
I'll also relink it on Zoom.
Thank you. Is there anyone that needs me to not go ahead right now? Is anyone really, really, really behind, still installing Conda or something like that?
Oh, I'm still installing condas. I tried to install the remaining 3 at the same time and it didn't work.
Oh.
You can still install it one at a time and it should be fine.
I'm gonna do that now then.
So you have Conda installed, you're just going to install the packages?
Yeah.
Okay.
Yeah, it seems like quite a few people do not have the Go Faster button on right now. I'm curious, what problems are you guys facing? How can we help?
The Go Faster is double.
If officers can click Go Faster too, that'll help us see the whole thing. There's a lot more blue now. That's good. That's
If
cool.
you're not installing anything, please also select Go Faster as well.
Why does PyTorch take so long to download?
PyTorch, yeah.
Oh my god.
Okay. If I don't know if it's safe to assume to go ahead, I'm going to say wait for a minute.
Okay, one more minute.
Yeah.
Cool. And then we'll go forward.
Yeah. I don't know if everything is going very, very smoothly, because in that case, that's really good. Or if people just don't want to speak up. But this is probably the smoothest I've seen these installations go, if it is the case.
Oh, I'm just taking a while to install each Conda if you want some feedback. Not sure everybody else.
Cool.
Thanks, that helps.
Thank you. Very smooth, cool. All right, so let's move to the next step. If you're a little behind, you can go ahead and just view the slides and copy paste the commands. Okay, so now if you have, okay, if you have everything installed, what now you could do is do some, go to your terminal. So Windows, go to enter command prompt. If you're in Mac or Linux, go to your regular bash terminal and type in Jupyter Notebook, just like that. So you're gonna run the Jupyter Notebook command in your terminal and press enter. And that's going to pop up a new web page. And so on your terminal, it'll look something like this. And essentially, that's just posting it onto this port. So when you are here, I'll let people get to here. You can go ahead and create a new Python 3 notebook. So when you're here, go click New Python 3, and you should be in your terminal. Sorry, in a notebook environment. And then you can type in import torch. And then if you press this button right here, it'll run the cell. And then you can insert cell below. And then run that command. Whether it's true or false, it's not a problem. It just means, do you have a GPU or you don't? I don't have a GPU with this computer, so it's false. Yes, that's going to be the next step. I just want to check if everyone has their Jupyter Notebook and PyTorch installed.
Is it supposed to say true if there is?
Yeah, if you have a supported GPU that is up to date, it will say just like for me, I have a 2070 Super on my computer and it says true. It could also say false if for whatever reason you don't have like an up-to-date driver or something like that.
Yep.
But that's pretty uncommon.
The command Jupyter Notebook is not working for me. I'm not sure.
Are you on Windows?
No.
You're on a Mac?
Yeah.
Cool.
What's happening?
Do you get any kind of error message?
It says command not found.
Did the conda install succeed?
Yeah.
Yeah.
Try reinstalling Jupyter Notebook and see if that fixes it.
Yeah, try the conda installed Jupyter again.
Okay.
Or maybe does Mac have a path you have to add stuff to?
Yeah, Gaurav, you can also put me in a breakout room with Pushpaul and then I can figure it out with her.
Can I do that? Let's see.
If you like Pushpaul.
I don't mind. Do I have to be in like a specific path? Or can I just be in...
You can run it from any directory.
Okay. Yeah, it's not working. And all requested packages are already installed.
Okay.
I have no idea how to put you in.
Gaurav, can you breakout room me? And,
I cannot. I'm gonna make you co-host. Can you do it? I'm not sure how to do it.
Oh, it might be disabled in the global Zoom settings.
Let me.
Here, I'll try to send you like a couple links that I found.
I see it.
if that
Okay.
helps.
Try typing conda activate because on some systems the conda environment will not be activated by default. If it is activated, you'll see in parentheses it will say base on your terminal, and that means the base conda environment is activated.
Wait, what should I type?
It should say parentheses and then base close parentheses.
Oh, it doesn't say that.
Okay, so that means the base environment is not activated. So just try typing conda activate and then try it again.
Okay, I'm going to put Andrew and Pushpaul into a room.
Oh, does that work now?
Yeah. Wait, one sec. Let me. It's.
Is it running now?
Work. Yeah, it worked.
It works.
Okay, it works. Oh, yeah.
Yeah. How do I exit the command again on terminal?
Oh, you can press Control C to stop it.
Oh, but then it stops. Okay, yeah, I remember. Okay. All right, thank you.
Cool. How's everyone else doing? Okay, cool.
Good.
So let's move on. Let me go back to the slides. Okay, so once you run Jupyter Notebook and you create a new notebook, type import torch, press run, and then run torch.cuda.isAvailable. And then after that, you will either get a true or false response, depending on if you have an NVIDIA GPU. After you open Jupyter, you can go ahead and type import torch, and then press run. And then after that, run torch.cuda.isAvailable.
Okay, you just showed us this, right?
Huh?
You just showed us this.
Yes, I just got a question, so I was just repeating it.
Oh. Gotcha.
Okay. Cool. So now, the next step is to go to this GitHub link, and that should take you right here. That should take you right here. So go ahead and go to code, copy this link right here, then go to your terminal to wherever your desired location is and clone this to that directory. So git clone, copy that URL. If you don't have git, then you can go ahead and just do download zip and unzip it and access the code that way.
Can you repeat that, please?
Yes. So you can go ahead and go to this GitHub link, which is in the slides, and the GitHub are in the announcements channel. And so you can go to the GitHub and then clone it. So to clone it, you go to code and then copy this link right here, and then go to your terminal, do git clone, and then copy the link. If you don't have Git installed, you can just go ahead and download this zip file that will have all the code and the data. I think we will get started with the actual workshop now. We have about 45 minutes left. If you have any questions, please put them in the chat, and the officers will help answer your questions. Okay, so when you get to Jupyter, you'll see a bunch of files. So first you'll see resources, data, workshop one underscore output dot ipynb, and then readme file. So for you that are following along and coding along with us, please use the workshop1.ipynb file. This has some blanks there that you can fill in. Jupyter, okay, so actually I think I might have skipped a step. Jupyter Lab is, so when you do conda install Jupyter, it allows you to have Jupyter Notebook and Jupyter Lab. So Jupyter Notebook looks like this. And so it has this kind of format. Jupyter Lab looks like this. So, oh, sorry, this is what Jupyter Notebook looks like. Sorry, this is what Jupyter Notebook looks like. Jupyter Lab looks like this. So you have kind of your file directory on the left-hand side and all of your interactive notebook that you get from Jupyter. So to launch Jupyter Lab, instead of Jupyter Notebook, you just say Jupyter Lab.
Is there a reason to pick one over the other, or are they just pretty interchangeable?
They're pretty interchangeable. It's just kind of UI differences. I prefer Jupyter Lab because I can see my directory and files while I'm coding. But largely UI differences. Okay, cool. So once you are here, yeah, cool. We can start the workshop now. So today we will be building a neural network classifier, image classifier, that will determine the differences between a muffin or a chihuahua. So as you can see, these are a bunch of data images that we collected. And so to the human eye, it might seem obvious which is a chihuahua, which is a muffin. But for example, that is pretty easy to mix up. So a network might not know that this is a muffin. Or actually, sorry, that's a chihuahua. A network might not know that that's a chihuahua, and vice versa. So we're going to create a classifier that can determine this with high accuracy. So in this tutorial, we'll cover 4 main steps. 1 is to build a neural network. 2 is to load the data. And 3 is to train the model. And 4 is to visualize the results. So remember, this is an interactive notebook. So you can run and play with the code as you go. So if you want to run a cell, you can click the cell and press Shift. You can. Is it Shift Enter or Control Enter? I believe
Shift
it's
Enter.
Shift Enter. Okay, I do Control Enter. Interesting. Okay, yeah. So either Control or Shift Enter works, and so that'll run a cell. So first, right here, we're going to import matplotlib. Can everyone see my screen fine? Should I zoom in a little bit?
You should definitely zoom in.
Okay, cool. Okay, cool.
Gavin asked, is there a difference between Workshop 1 and Workshop 1 output? Yes, there is. Workshop 1 is where the stuff is not filled in yet. Workshop 1 output, where everything is filled in already. So you should be using Workshop 1. The output is for your later reference.
Echoing? Or is someone else's mic not off or something?
It is echoing a little bit. Maybe I just speak really loudly. Gavin, you should look at the one that does not say output.
Yeah, so you should look at the one that does not say output, correct?
I mean, if you're following along, that is. Yeah, if you're following along with us encoding it, do the one that does not say output.
Yeah. So first we will import matplotlib. This is used to plot images or plot data. And we have this inline command to be able to show the plots in the Jupyter Notebook instead of in a new window. These are our deep learning imports. So import torch, this is the PyTorch framework. Then from Torch Vision, we import some packages, data sets, models, and transforms. And these are to help us import our data and use models and transform our data as well. And the rest of these are for neural network modules, some special functions and optimizers. So to run this, just Control Enter or Shift Enter.
Yeah, and you can tell when you've run it when there's a little number on the side. See how Gaurav says 3? Make sure that you actually run it and there's a number there.
And if you run it again, for example, it'll say 4. So it'll just increment everything. If you want to reset everything, for example, something's broken, restart kernel, or restart kernel and clear outputs, whichever applies. Okay, cool. Okay, so now we'll build our neural network. So as Vlad was mentioning in the actual presentation, the neural network has several layers. This neural network has one input layer, one output layer, and 5 middle layers or hidden layers. They're called hidden layers. And so the number of output neurons right here are going to correspond with the number of things we're classifying. So in our case, we're trying to classify between muffins and chihuahuas. So we will have 2 output neurons. So we will define an architecture for R2 class muffin versus chihuahua classifier. So for us, we can now define the image height and image width. So right here, just go ahead and write 224 and 224. That will be the input height and width. And then we're going to create our own basic neural network. So to do this, we're going to import from nn.module. This is the PyTorch neural network base class. And so this has 3 functions that we need to define. So one is an initialization. So what layers you have to initialize your layers. And then you have a forward pass. You have to define the forward pass. And then, actually, sorry, there's only 2 for this one. There's only 2 functions for the NN module that are required. So your init and your forward. Backward pass is automatically taken care of by PyTorch AutoGrad.
Any questions?
Yeah.
I have a question. Gaurav, do we know that the images are 224 by 224? Because if you actually look inside the data folder, you can see that not all of them are square.
Yes. So what this will, good question. So all the data might not be the same size. However, we want to crop all the data to be the same size. So what we'll do is we'll define this input height and width. And later on, you'll see that we'll also define transforms. So a little bit about transforms. This will allow you to pre-process your image data. So what pre-processing basically means is we're going to cut all of our data, crop all of our data to be the same size. So the neural network is exposed to only the same size images. We'll also do some other things that like normalization, and I believe that's it, to also pre-process our images.
So why would we want to
also for the
same size?
Sorry.
Oh, you can go ahead first, actually.
I just had, like, did you import the whole folder of the Chihuahua versus Muffin on the Jupyter Lab?
No. So okay. So the best way to do this is wherever you installed your or if you did your git clone or if you did a download zip, wherever you downloaded that code, go to that directory. So cd into wherever that directory is, cd into that path, and then from there you should launch Jupyter Lab, and then it will show up.
Oh, okay. So we don't have to like upload it, but we can just like put it in the same folder.
Correct. So you just have to navigate to that folder.
Okay.
Right, and then start Jupyter Lab from that folder.
Yeah. Yeah, and you were saying?
Right, Gaurav. So thanks for coming, Felix. See you next time. So for the cropping of the images, why do we crop all of our images? Because isn't that essentially throwing away information that could be valuable in our pictures?
Oh, you want them to answer? You want us to answer?
I'm guessing that this could be a question that people have. And I guess if anyone in the audience knows, feel free to answer. If anyone has a guess, why do we crop images?
Is that to Gaston or to me? I can take it. So the reason we crop images is because sometimes, well, an example of why is we will do center crop at times, and the reason is there will be more informative information in the center, that's part of the reason. Another reason you could do it is you want to limit some of, you might want to limit some data information from leaking in. So you can overfit your model if there's data, like if in every image you have a Chihuahua, there's like a green background, and in every image there's a Muffin, there's a blue background. The model can overfit to see that. So that's possibly—
That's a good answer. That's a good answer. There's actually an even stronger answer. Gaston is going to answer, so I don't know if Gaston knows.
I might not know, but I would say they could be different sizes, and also if the images are too big, it will take too long to train.
Sure, that could also be an answer. The strongest answer, though, is that if they're not all the same shape, they're not going to fit in your network. So your neural network, actually the architecture is kind of brittle. You can only take one specific size as input. And this is because in our neural net, we connect all the weights to all the inputs, and therefore we have to define how many weights there are to connect to all the inputs. So that's why we have to crop each of our images first.
Yep. Great, thank you.
Teo says, can't you squeeze the JPEG file into that certain size? Yes, that's essentially what we do. Like you can resize it as well before you crop. Actually, that's more common. You resize it down to the scale first, and then you crop it.
Yeah. So, I mean, you could do that to the JPEG files, but we just do it through the code within, Torch Vision gives us this nice transforms feature, and so we just do it within the code. So that's basically pre-processing our data.
Right. It will pre-process online as the code's running.
Yeah. Okay, so right here, we'll define our input dimension as 3 by 224 by 224. And the number of in features. The number of in features is just going to be the number of RGB pixels that we have in our image. So we have 3 by 224 by 224 pixels. So that's going to be how many input features we have. And so then we have these things called linear layers. So these linear n dot linear. So the linear layers are basically going to be these connections between one layer to the next. And so we're just going to call the linear layer, and it takes in two parameters. The first parameter is how many features am I taking in? How many features am I taking in, and how many features am I pushing out? So here we will take in the number of features of the images. So num in features, output 128. And then it'll go from 128 to 64, 64 to 32. And so these are our hidden layers. And then our output layer, we want to output 2 because we want to determine whether it is a Chihuahua or a muffin. So we'll output 2. So to recap, our input layer takes in the number of in features and puts it down to 128. Our hidden layers also decrease it from 128 to 64, 64 to 32. And our output layer will put output features of two output features. Okay, cool. So then in our forward pass, this is where you will give your prediction, output prediction. And so what we do here, this input X right here, this into this definition, that's going to be the data that you pass in. So this is going to be your image tensor. So what is a tensor? A tensor is when you input an image, it's going to be a 3-dimensional matrix of numbers. Jason will talk about this a little bit more. And so we put that into a form called tensor. And tensor, all it is it's just 3D matrix or 4D matrix or ND matrix, and that will allow you to do GPU computations. So here, we're basically going to get the batch size. Batch size is, this will be something that Jason will explain as well. And what we're gonna do is pass it through our layers. So we're gonna take our input X, put that into a parameter, put that in as the input to our layer 0. So layer 0 is this first linear layer. And then we're gonna surround that with a ReLU function. ReLU function is an activation function. Yeah, so an activation function, the goal of an activation function is to, well, there's several goals. So one is to normalize the input. The second is to add nonlinearities to your data. And so generally it's very, very useful to use these activation functions. So what we'll do is for each layer, we're going to wrap, we're going to input our image into it and then wrap each layer with a ReLU function. The ReLU is an activation function. So we put it through layer 0, 1, 2, and 3. And then lastly, to output, our output is going to convert, so the output of this function right here, can anyone tell me how many output neurons does this function have? How many features is this function going to output?
2.
2. Perfect. That's correct. So what we want to do from that, now we have our two outputs. Now we want to convert that into probabilities. And so a very nice way to do that is to use the softmax function. So we'll convert that into probabilities. And these probabilities can be interpreted as, what is the probability that this is a Chihuahua? Or what is the probability that this is a muffin? And we're going to return these probabilities. So we define this network. And now we are going to run this onto on our device.
Wait, hold on, before you go on, that was a lot of information at once. So any questions here?
First,
Yeah, sure.
I wonder if we can just do this with one hidden layer, but not two.
You are free to experiment. Go ahead and try that out. So if you want to try that out, just go to the code, comment this out. Oh, so actually, if you are going to try to experiment that, you might have to change some of these numbers.
Yeah, which actually brings to the second question. What are those numbers again?
Oh, great question. So these numbers, so our network overall is going to look like this. So what we're doing is we have this 3 by 224 by 224 image. And what we're doing is this is a 3D tensor. And so we're going to collapse it into just one very long input of all of the image, of all the pixels. And what we're going to do is that's how many neurons you have in your input. So you're going to scale that down to having 128 features, and scale that down to 64, 32, and lastly 2. So those numbers are corresponding to the number of features that we have, or the number of neurons in each layer.
Mm-hmm. Wait, so
when you say,
so you start with 128, right? Where does 128 come?
You're free to use other numbers as well. So the only requirement is if you change this, so you don't want this to be 128, you want this to be 256, then you are going to have to change the input of layer 1 as well. So you'll have to change that to 256 as well.
Yeah.
Would you leave the number at 64 as well, or would you have to just divide it by 2 again?
No, there's no requirement. As long as the output of one layer and the input of the next are the same number of features, your network will work fine.
Yeah, great questions. Any more questions?
I have a question.
Yep.
So when you put multiple layers, so when you said you have 120 and 128 as the first layer, does it mean that our model will first categorize all the JPEG files into 128 categories, or I'm not kind of sure what the neural network does yet?
Yeah, good question. So what you can think about it as, so it's not categorizing it into 128 categories. So you can think of categories as the output. So we classified this as categories because that's what we're trying to predict. The hidden layers here are the feature representation. So what that means is it's going to take this input image and try to figure out where are the edges, where are the kind of low-level features, and as you progress through the network, it's going to try to learn higher-level features. Higher-level features are basically combinations of lower-level features. So like Vlad was saying, lower-level features are like edges, and then higher-level features are combinations of edges, perhaps shapes, perhaps eyes, perhaps things of that nature. Does that answer your question?
So from the information from the information from the lower layers, they will again combine those layers into higher level layers, and you're gonna just crop it down to 2 options.
Higher, yes. So you're going to have 2 options or 2 output neurons, and that's going to represent, yeah. So you're basically you're basically pushing the number of neurons from the input image representation and pushing it down to this output 2 neurons. And so why does this work? I guess that's the question. So the reason this works is, first of all, it's not going to work the first time you run it, because the first time you run your forward pass, this is not going to work because your network, all of these features are parameterized by some weights. So these weights are what are learned, And so the way this is learned is by doing a backward propagation. And so you'll do forward propagation and then backward propagation. There'll be more code on how this works later. But yeah, so it's basically, you're basically setting up the architecture of the neural network so that it can learn. But how does it learn? The answer will be shown through code in a bit.
Okay.
Awesome. Any other questions?
When I run it, when I run the shell, it says that NN is not defined.
Did you run the
Yeah.
very first one?
Yeah, I ran them all, but maybe that was the problem.
Import torch.nn as nn.
Yeah, check if there's a little number.
Oh
on
yeah,
top.
I think, yeah, now it's working, I think.
Okay, cool.
Thank you.
Question.
Okay, cool. So the last thing now is we're going to, now we have our neural network architecture and we're going to push this to a device. So all this does is it's going to define a device. So if you have a GPU attached to your machine, it's going to use the CUDA 0 device, which is just the first CUDA device. If there is no CUDA available, it's just going to use your CPU. And so once this device is defined, you can replace that question mark with my Skynet.toDevice, and that's going to load your neural network to your device. So whether that's a CPU or a GPU. And the output is going to look like this. So you have 4 layers, and so your linear layer has 15,528 features, and then your output features are 128, 128 to 64, 64 to 32, and finally 32 to 2. And so this is what the neural network looks like. Okay, any questions here?
Yeah, I have a quick question. This is probably about Python thing. So when you say my Skynet.to, right, device, what's .to do again? Because my Skynet, this class doesn't even have that .to member function, right?
Okay, so that .to function is defined in the base class, the nn.module base class. So you don't see it in here, but there is a .to function.
All right, I just saw that. Sorry, I just realized that. All right,
Yep. No worries. Good question. Okay, great. Then in that case, I can hand it off to Jason to continue talking about data and data loading.
All right, so I guess I'm gonna continue with Goar of sharing the screen. So yeah, what is data loading? Well, we have all these images of chihuahuas and muffins, and we need a way to get them to our model, and that can be a bit complicated. So we're gonna rely on some borrowed tools to make life easier on us. First of all, we need to divide our images into a training and testing set. So this is a very good analogy. If you threw like your kid, your like grade schooler, into like a math exam with no practice, they're not going to do very well. So that's why they have to do a lot of homework to figure out their times tables and whatnot, and then eventually they'll be ready and strong enough to answer any question that they see on the test. So that's basically what we're trying to do here. We have to train our model on some pictures of chihuahuas and muffins, so it gets an idea of how to differentiate between the chihuahuas and muffins before we can throw some totally new, never before seen pictures of chihuahuas and muffins, and then we're gonna get the computer to test it and see if they actually know what they're doing. So if you run these commands, if you import OS. I think this works differently if you have Windows or Mac, so our officers might have to help you out with this. But yeah, if you look and you run these commands, you'll see the contents of the folders. If these commands don't work, you can just like go into the folders and look at them yourself. So if you go into
just
the,
a note,
yeah,
if you have Windows, I believe all you have to do is replace this / with 2 backslashes.
yeah, that might work as well.
Yeah.
Yeah, but if not, you can just like literally go inside the folders yourself and you can see it yourself. So inside the folder, we have the data folder is where we have all of our pictures of chihuahuas and muffins. And inside the data folder, we have a split between train and validation. So basically, we've taken a subset of all of our pictures and put them into training, and then taken the other what we didn't put for training and we put it into validation. Validation is for testing. So the default numbers you want to go for is you want 80% in training and 20% in validation. That's like the standard for most ML projects. Of course, if you know what you're doing, you can decide that, maybe I don't need 80% training. I can deal with 70%. That's fine. But yeah, if you look inside the training and the validation folders, you can see the pictures are also divided into Chihuahua and Muffin pictures. So by dividing them into these separate folders and making sure that we don't have any cross-contamination, we have a way for our model to figure out the right answer. That's basically our labeling. So which means all Chihuahua folders should be in the Chihuahua, or all Chihuahua pictures should be in the Chihuahua folder, and all Muffin pictures should be in the Muffin folder. So if you mix these up, then your models are not going to be able to determine if they have the right answer or not. So that's very important as well. Okay, so if we run these, first we have to import the image library from Python image library. And if we run this code, this will allow you to print the image of chihuahuas and muffins onto your screen, onto your Jupyter notebook. And as you can see, we have some chihuahua and muffin pictures, but if you notice, as Gaurav mentioned earlier, they're not all the same size. The first one has, over 350 pixels. That's what those numbers represent. So it's like 300 by 350 pixels in size, while the others are like 180, 180 or so. That's why they're inconsistent, right? So we have to make sure that they're consistent later on. But yeah, this is another image showing us how we've split our training and testing. Okay, so now we have to load our data. So PyTorch generally doesn't react well to like straight up images. Yeah, so we have to translate the image into something that PyTorch can understand better. And what they understand better is called tensors. So tensors is just like multi-level matrices and arrays. It's a kind of complicated concept, but to translate what the tensors represent in the picture, you all know that in computers, color is mainly defined by 3 values, which is RGB, right? Most of you should be familiar with this concept. So if we split the image into 3 different tensors, each tensor can represent the color R, G, or B. And the values inside the tensor can refer to how much of that value we're going to be using for that one particular pixel. So that means we have to, if our default is 224 by 224, we're going to have a tensor which has 3 224 by 224 arrays. I don't know if you could call it arrays or matrices. And each number in that 224 by 224 array it represents to the, you know, the value of RG or B, you know, on that pixel. So yeah, by combining all that information, you should have a tensor representation of the image. Does that make sense to everybody? Any questions? Yeah, this is a kind of a lot to cover. So, all right, we can, I guess we can move on. Okay, so we have to convert our image to tensors, which is not something us humans can do very easily, which means we're gonna rely on some Python magic, PyTorch magic to help us out with that. We use data loader, which helps us package our image into a convenient box for our model to use, which is the tensor. So first we have to define some transforms that Gaurav mentioned a bit earlier, which will help us convert the image into tensors. Yeah. So we have that function right there. Normalize equals transforms that normalize mean and std. So what this is normalizing means we have to like, how can we explain that? Gaurav, do you know the normalize?
Isn't it just trying to make sure that everything's within like a certain numerical range so you don't encounter any overflow or underflow?
Right. Yeah.
Yeah, I believe it's to normalize the image distribution.
Yeah, that makes sense. Yeah, so this is just to make sure that everything is in a similar range like Gaston and Gaurav said. And then next we have a resize transform. So this is to make sure that each image becomes 224 by 224 pixels height and width, right? That's also important. And we have to do it for both the training set and the validation set. So that's why we have two different resize transforms over there. Yes. Okay. And then we apply those transforms to our data set. First, we have to make a variable that holds our data sets, training and validation. Okay, we can go to continue, Gaurav. Gaurav?
Yeah, can you see my screen?
Yeah, you can scroll down.
I don't think you've explained this code yet.
Oh, okay. So like I said, there was the resize and then the normalize, right? So we defined the normalize above, and the resize was the one.
Wait, do you see the data loader's code?
Transform function. And then this, is the data loader. Right, okay, yeah. So we have two data sets that we need to load in, which is the training data set and then the validation data set. And then if you look in the middle, we have some variables. We have batch size, shuffle, and number of workers. So batch size, basically, computers are very good at multitasking, basically. So we don't want to process each image one by one if we don't have to. So we can do 8 images at once. That's what batch size is. All right. And shuffle, we don't want to keep feeding in the same images in the same order, because the computer might learn to just focus on that same order. So we want to be able to shuffle them around to make it a bit more challenging for our model. And num workers is basically for multi-threading, I believe. Each worker can handle a different batch of images. Okay, so that's all that. And then this shows us the whole tensor thing. So this is just like a big, massive tensor that holds all the information that we've just defined. It's hard to understand, but looking at the very last line, you can see a small array of just ones and zeros. So if you look, you can see there are 4 different values. and not 4, what I'm saying. There's 8 different values. 8 different values, which corresponds to the batch size that we just did, which was 8. So each of those values represents to each of the 8 images that we put in the batch. And what do you think? Can anyone guess what the 1s and 0s refer to?
Whether they are chihuahuas or muffins.
Perfect. So one refers to, I guess, muffins probably,
A
and 0
chihuahua?
refers to chihuahua probably, or it could be the other way around. It depends on how the model read in the input. So it could be either way. I'm pretty sure 0 is chihuahua and 1 is muffin in this case, though. Okay. Any questions so far? That whole section was pretty information heavy, so I definitely don't want anyone to be confused. Okay.
So we can like increase the batch size to like better compare our data.
Yes,
sense?
definitely. If you have like a very powerful CPU or GPU, you can put in process more images at a time, and that'll reduce your training time by a lot.
Oh, okay. So we can process like 100. If we do the batch size to 100, we can basically process like 100 images of chihuahuas and muffins at the same time.
Basically, yeah.
Okay. Thank you.
Pushpal, the answer to your question is the train transforms and the validation transforms.
All right, thank you.
And the next one is just define batch size as 8.
And this is more so used for vision, right?
What is?
Could be
the batch training or
the batch training, because we're comparing images, so that would be more so for computer vision.
Yeah, it's not specifically used for computer vision. In fact, like all machine learning would probably use batch sizes because it's just more efficient that way. Since our computers can do multiple tasks at once, it'll just help things move a lot faster.
Yeah, so for example, like you can like in computer vision, you load batches of data, batches of images. In other cases, you can load batches of data more generally.
Yes. Okay, so now comes the fun part where we've done all the hard work and we've defined our model, how we load the data and all that. Now we actually get to train the network that we built, and we're gonna find out if it can actually classify between chihuahuas and muffins. So we need to do a forward pass and a backward pass, and that GIF down there gives us a pretty good visualization of how the forward pass and the backward pass works. So the box on the left is the input, and the number on the right is the output. So here is a neural network that's trying to convert, I guess, someone's handwriting into number text. So you can see first we have an input, which it sends all the things forward into the output layer, and then it propagates everything backwards based on whether it got the answer right or wrong. Yeah, so it's a pretty cool thing to watch. But now we have to define the loop for ourselves. So this one can be, it's definitely a lot of code, but it's pretty intuitive if you can understand it. So TQDM is just a library that makes some visual loading bars to give us some idea of when the thing will be done training. So it's not like super important, but it makes it look nicer. But the train model, this is our training model function. So we have to train the model using all these inputs, which is our model, our data loader, the loss function that we've defined, the optimizer we've defined, and number of epochs. I don't remember if Gaurav went over this, but epochs basically means how many times do you want to run this training loop. Generally, the more times you run it, the better your thing's gonna be. But of course, there is overdoing it, where if you do it for like 1 million epochs, it's probably not going to increase by that much for the amount of work that you're putting in. So picking the right number of epochs is also a skill that you have to finagle with. Okay, so we have our loop for each epoch that we put in, and then we're gonna put a loop for each phase. So we have two phases, which is training and validation. So once we train, then we can evaluate, right? That's what that if statement means. And we call the train and eval function. That's probably defined later on. We also keep track of our loss and our number of correct guesses. Yeah. So loss, as Gaurav mentioned earlier, is a way of figuring out how off we were. And of course, then we want to keep track of how many guesses we got correct. Okay, and for each input and label, so input refers to the tensor with the RGB values, and labels is the 0 or 1. So of course, we want to train only on the inputs. We don't want to put in the labels as an input, otherwise that'll make it too easy. Yeah. And then we do our forward pass where we put the inputs through our model, and then that gives us the outputs from our last two nodes at the last layer. And then we have to calculate our loss using those outputs and comparing it to the labels that we get. Does that make sense to everyone?
Mm-hmm.
Yeah.
Any questions till this point?
Yeah, so you can imagine that the outputs are going to be either a 0 or 1, and then the label is going to be a 0 or 1. Actually, no, the outputs are going to be a decimal between 0 or 1 or something, and it's going to...
Correct, it's going to be a probability.
Yeah, it's going to probability. So it's going to be like, 60% chance that this is a Chihuahua and 40% that it's a muffin. So you obviously take the higher probability. Okay. And then if you're training, you do a backward pass. So the backward pass, as Gaurav mentioned, is how you try and correct the wrong assumptions that you had earlier in the weights or whatever. So you use your optimizer function by clearing it out, and then you do a backward pass using your loss that you calculated. And then you step your optimizer function based on that calculation. So that updates the weights, and you only do this during training phase. You don't want to optimize and stuff during your validation phase. Otherwise, it's just a training phase again. Okay, and then now we keep track of our running loss, which is just how off we've been, and then our predictions, which is we take the maximum probability of our prediction and then assign that label. And then we figure out how much correct we got. And then finally, we have printing some data that makes it easier to read at the end of it. So the loss per epoch and the accuracy per epoch. And the error and accuracy. So you'll see that when we run everything. Okay, so we got through all that. Any questions? Okay, so loss function and optimizer. So this is where we define our loss function and optimizer. We're using some standard functions, which is cross entropy loss and stochastic gradient descent. There are a lot of different, a lot of these functions. These are just some of the most common and popular ones that we're going to be using. Yeah, and yeah, so if you look at the GIFs here, this kind of shows how the loss and optimizer works. So this is like we're trying to fit the curve to the scatter plot, right? So with each iteration, the curve is going to get better, and the ball rolling down the hill is just basically, the computer trying to find the path that, best minimizes the error. So the lower down you are, the less error that you have. Cool. And then now we actually run the training function.
So it looks like TQDM was depreciated.
Oh man.
But so we ran this for 3 epochs. Oh, sorry, I took over your role. Go ahead. Sorry.
No, go ahead. Yeah, you can talk about this, Gaurav.
Okay, cool. So yeah, so first epoch, this is our train error, and this is our validation error. Second epoch, you can see the train error is decreasing and the accuracy is increasing. Same thing with the third epoch, accuracies got up to 90% on both train and validation.
Okay, yeah, so this is just some code that will, the computer has already done the training and testing. Now we want to make the data pleasing to our eyes so we can make sense of it. So this is just some code that prints out the outputs like so, and you can see the predictions that the computer has made, and you can, see for yourself whether we did good or not. So as you can see, most of the chihuahuas have been correctly labeled as chihuahuas. Some of them are kind of questionable as they have some muffin percentage, but in the end, they are definitely all chihuahuas.
Most of the muffins are misclassified though, or
yeah,
50-50.
That's true. So if it's 50-50, that might seem okay, but it's basically just a coin flip, so that's not very good. As you can see, the second muffin on the top row kind of does look like a chihuahua, in my opinion, actually.
Oh, sorry, I moved it.
Yeah.
Which one?
Actually, there was one muffin chihuahua that was also 50-50 as well.
Yeah.
So yeah, it looks like actually, yeah, our model has a very hard time distinguishing between muffins specifically. Like chihuahuas, they get down, but I guess muffins are very, very difficult. So as you notice, this is kind of a hard problem for computers, even though, it may seem obvious to us. But yeah, that's it. Once you've done it, you've successfully trained a neural network. Any questions?
Is there a way you can improve the percentages?
Good that you ask. So that's sort of our challenge to you. Can you do better? So there's several things you can edit that can maybe improve or affect your accuracy rate, such as the number of epochs or the learning rate. So this is stuff you can fiddle around with and try and, change to make better. But there are definitely ways to make the accuracy better in this case, yes.
Yeah, so feel free to mess around with this. This is specifically in an interactive notebook, so you can edit it easily and run it easily. If you're trying to try new parameters to try to get higher accuracy, go ahead and mess around with the number of epochs, with optimizer, the architecture, things of that nature.
Yep.
Cool. Thank you, everyone. Thank you for coming to our workshop. I think that concludes it for today. We went 10 minutes over time. Thank you for staying past that time. Yeah. Any questions before we end the call?
So obviously there was a lot of stuff. This is a question. So obviously we did go over a lot of stuff today, right? So like for, I guess you guys that did make this tutorial, right? What would you guys grade it for, like, let's say like 1 out of 10 for difficulty, especially for beginners, like me and a whole bunch of other people here, because that was definitely a lot. Like I kind of got lost.
Yeah. Yeah, we
but
know it's
it
a lot,
was
so thank you so much for hanging in there. Definitely a lot of stuff today.
Luckily, you need the most important takeaway I'd say from this is more understanding the workflow you need to do rather than the exact code, because whenever I do deep learning, I do a lot of copy paste. But since I understand the general workflow, I can succeed. So the general workflow of like the pre-processing, setting the hyperparameters, training, testing, reviewing, and iterating is probably just getting to know that would be the first takeaway I would suggest you to think about more than the exact code that's written.
Yeah, and to answer your question specifically, Ulix, this whole workshop is actually based on a meme project that I had to do for my AI class. This was the very first AI project that I had to do, and it was definitely difficult as a beginner trying to figure out everything. So if I were to rate it, this is probably more of a middle level, whereas I tried to start it as a beginner, so it was kind of painful. There are a lot of easier machine learning projects that you can start off with. One of the most well known is the Iris project, I believe. We did a workshop on that like a long time ago, but that's like the standard beginner machine learning workshop if you want to take a look at that. There are lots of well documented tutorials on how to do that.
I see, that's cool. Yeah, that's a lot of great stuff. Thanks, guys. It's just my brain's exploding.
It is
This
on
will
our
all be
notebook.
put on YouTube, the YouTube channel, right?
Yes.
Okay. Thank you.
And we know it can be quite challenging, but that's why we're here, to try and make that process easier for you guys. Because even though there is a lot of work, there's also a high payoff, and you get to do really cool things in this field. So hopefully that you guys will stick with it, and we'll help you get there.
Yeah, I think the important question to ask is, can we use machine learning to predict who's going to win the finals tonight or in the last couple of weeks? You know,
Yes,
Well,
actually.
obviously
if
it's
you
my
have all the data to back it up, then yes.
Somebody actually did a project like that in one of my classes to
really?
predict like who would win over the course of a season, and they got pretty good. I think they were like 70-ish%, but it required a lot of data. Like I think they had like the past 5 seasons worth of data.
Yeah.
That's
So, but it is doable. You just need a lot of data and a way to be creative about it.
Yeah, theoretically, anything is possible with enough data. Theoretically.
Yep, more data equals better performance, usually.
But Miami all the way.
Oh, Gaurav, should we just briefly tell people what's going to happen next week?
Yeah, so we will keep having our weekly meetings like every Friday. Next week will be our first committee meeting, so we will all meet in our committees and respectively start learning about whether it's machine learning or computer vision, reinforcement learning, etc. And yeah, so come back next week and we will have more fun learning. Yeah, thank you for joining us and look forward to seeing you back next week.
All right, before we end the session, I just wanted to quickly check in with my computer vision. I think 2 of my members are here. We were considering possibly joining the computer vision with the natural language processing committees. So but it's ultimately up to you guys, what you guys want. So if you guys are interested, just let us know by next week. I did bring it up in the computer vision committee, so let us know what you guys think, both the people from natural language processing and the computer vision committee. It's totally up to you guys. I think there's going to be pros and cons to both approaches, so whatever you guys want.
Cool, thanks.
Awesome.
All right. See you guys next week.
Thank you. See you next week. Bye, everyone.
Bye.
Take
Thanks,
care.
everyone.
Bye.